Let's start the recording. We are good to go. Welcome back. So we are finishing up the section on the chapter on consciousness and the section on drugs. So before we delve back into it, wrap up this section, I just want to ask again, just as I did for sleep, why are drugs included in a chapter on consciousness?
Because drugs alter the state of consciousness, either make it like, where you're not as conscious or you're hyper conscious, I guess, depending on what kind of drug you're on.
True. And so how exactly does it alter that consciousness then? How would you describe that?
For example, LSD will make you feel like hyper conscious, like you have a higher state of consciousness, so you feel like you're like, I don't even know how to explain it, but you're like extra aware of everything around you. While like say alcohol would be like, you're more free. You're more free, but also like I don't know, sluggish, drunk, tired. Later, you're not as quickly it just hinders the response, I guess.
Okay.
Find my words.
No, you're good. So underlying all of that, you're right. It's going to change your experience in some way. And so underlying that change in experience, we're talking about a change in how your nervous system is working, right? Our definition of consciousness is your experience of all the mental activity that's going on in your body at any given moment. So when you take a drug, what you're doing is you're altering something about how your body, how your nervous system works. So if you're altering that, you're going to change that conscious experience that goes with it, how you're perceiving the world around you. So with something like a hallucinogen, LSD, a good way to describe that would be it alters how your nervous system interprets sensations. You can get some really weird effects with LSD where certain sensations are extreme. That is, they're overblown relative to what they otherwise would be. Or in some cases, it can cause you to experience synesthesia, which is when you experience one sensation as a different sensation. So suddenly you feel like the number 5 has a particular smell to it whenever you see it. So some really weird stuff. It alters how your nervous system perceives the sensations that it picks up on. All right, good. So just like I did last week, what I'd like to do is continue with this motif that I've given you. That is, how your brain interprets information need not match reality as long as it enhances survival. So I want to go through that again and really emphasize how drugs are something that people can start to use because it's a tool to them, because it's useful to them in some way. Now we can talk also about how overuse of certain drugs or dependency on certain drugs can actually be more harmful than it is helpful. But what I've often found is that people think that, that you might develop a dependency simply because you enjoy a drug. You try the drug once and then you enjoy it so much that you just use it again and again and again. Or you use a drug and it somehow parasitizes you. It like takes away your personal your agency, your control over yourself, your ability to think for yourself. And there's a little bit of each of those to that, but I think a really good way to understand why people form dependencies is you have to view drugs as something that in certain situations can actually help someone. And let's go through those 3 classes of drugs to try and pinpoint how each type of drug could, in certain situations, actually aid someone in their survival or help them to overcome certain problems. So again, how do stimulants alter perception? What is physically happening within the nervous system? Well, what is changing about mental activity when you take a stimulant? Cocaine, nicotine, caffeine. etc. Meth. What is changing? What is how do stimulants alter perception?
Make you use up energy quicker.
Good. And exactly, it increases the activity of the nervous system, and it causes you to use up energy more quickly than you otherwise would. Again, it does not give you energy. Taking meth is not like the same as eating a hamburger, right? The hamburger will give you energy because you're breaking it down into sugar, you store that sugar, or you use that sugar to fuel your body. Exactly. Stimulants, on the other hand, are taking your nervous system and they make it work harder than it otherwise would. It increases the activity. And the metaphor that I used was it overclocks your nervous system as much as you could overclock a computer, make it run beyond its specifications. So it can, as much as you can be stimulated by a stimulant, it increases the activity, it can also wear you out really quickly. That's why people who are dependent on caffeine or really like Monster energy drinks or et cetera, you experience that elevation, that stimulation, but then there usually comes a point where you crash because you're using up that energy that you have, and until you get more, it can be kind of hard to get going again. Okay, good. So stimulants are altering perception by causing the nervous system to work harder than it otherwise would, and specifically, they stimulate the sympathetic nervous system. That's your fight or flight section. We learned about that way back in chapter 3, the sympathetic nervous system. So blood rushing to the extremities, perspiring, you sweating, blood rushing, kind of, you can get red cheeks, heart rate increases, etc. So you're stimulating that part of the nervous system, making you consume energy more quickly than you otherwise would. How do depressants alter? Oh yeah, go ahead. Yeah, sorry.
I was gonna say, I was once told that caffeine suppresses appetite.
It does. Why would it, given what you know?
Because like you said, like caffeine is a stimulant which makes you go faster. Say that Monster energy drink. I'm guessing. I'm not quite sure why it's an appetite suppressant.
Does anyone want to take a guess as to why caffeine is? All stimulants are appetite suppressants. That is, you will not be hungry as often. So the sympathetic nervous system is that thing that you stimulate, your fight or flight. It's that thing, it's that part of your nervous system that gets stimulated when you need to get something done. If that's activated, that means that your body is preparing to move and to use energy rather than to accumulate energy. The opposite of the sympathetic nervous system was the parasympathetic nervous system, and that was your rest and restore, rest and relax. I forget exactly how, there are different ways of saying it. But it's the opposite of the sympathetic nervous system. It's when you eat a big meal, that's the part of the autonomic nervous system that activates, that causes blood to stay near your internal organs, that gets you to kind of rest, to stay sleepy, to potentially sleep. So the idea here is if you're stimulating the sympathetic nervous system, then your body is prepared to move and do things, not to sit back, relax, and digest. So by stimulating the sympathetic nervous system, it does that in and of itself suppresses appetite because you're not preparing to eat, you're preparing to work, to do stuff. So yes, that is true.
I guess this explains why every time I drink an energy drink and eat breakfast at the same time, I get heartburn.
Yes, and in terms of heartburn, heartburn's going to come about by you having too much acidity in your stomach. That's what heartburn is. And so if you drink Monster Energy, and depending on what you eat for breakfast, if you eat like the traditional, like something meaty or something that would have acid, that is acidic, maybe you have like orange juice or something with it. Yeah, you're getting kind of a double dose of acidity in there, and that'll give you heartburn. I also think that being stimulated can lead to can also stimulate some of the acidity production within your stomach, and that can lead to heartburn as well. Yeah. Okay, so how do depressants alter perception then? Good. So they slow the activity of the nervous system. And there's something else that I want to emphasize here is that depressants as a category will tend to slow down the overall activity of the nervous system. But as we've seen with alcohol, very often what they'll do is, in addition to doing that, making the nervous system work more slowly, it will target a particular part of the nervous system and make that work more slowly, or especially more slowly. That is, it will inhibit those neurons from firing. Exactly, it inhibits neurotransmission. And so what you're doing with alcohol, for example, is, yes, alcohol is a general depressant. It will cause your nervous system to kind of run more slowly or inhibit the activity within your nervous system. But specifically, it also targets that prefrontal cortex, which is the part of your brain that inhibits you, that causes you to not do things impulsively. And so that is why you are more likely to do things impulsively when you are drunk or when you are tipsy, is you are inhibiting the part of your brain that inhibits you. So yes, general depressant slows the activity of the nervous system, also can target very specific parts of the nervous system as well, and which is how you get these unique effects of alcohol versus opioids, which specifically target the pain receptors, et cetera, et cetera. All right, and then what do hallucinogens do? How do they alter perception? This is what I just described with LSD. Yeah.
It like alters your state of like mind, your consciousness, and like I said, it like makes you feel like you have a higher consciousness.
Yes, but let's make sure that we can very precisely define what that means. So when you're altering the consciousness, when you're expanding your consciousness, what exactly is happening? That is the experience.
Yes.
Yes.
She took my words.
Yep, perfect, yes.
I couldn't find the words.
No, you're good, you're good. That's why we do this. It alters how your brain interprets sensations. Yes. Okay, so given that these categories of drugs exist and people can very much enjoy drugs and they use drugs, can altering your perception in these ways potentially aid your survival somehow? Can we apply this logic that people are seeking out this altered state of consciousness because in some way they at least think it helps them? Let's tackle stimulants. Stimulants are probably one of the most widely used type of drug. How could stimulants help someone to survive and thrive?
In a way, it does and it doesn't. Say like you barely get sleep at night. You gotta get up early in the morning. You got a meeting to go to, and you're like really running low on energy. So you grab yourself a Monster or a 5-hour energy before you go to work. It's gonna boot you back up. You ready to take on the day. Usually a Monster lasts me all day. But let's say, I don't know, you're out stranded in desert island. Your only thing to drink is either a Monster or some water. The Monster's not really going to help.
Right, right. So yeah, these stimulants are going to be a tool that in very particular circumstances are going to help you with certain things. If you have to get something done, if you have to give a lecture, maybe you're going to drink some tea with a little bit of caffeine in it so that you can keep that energy up. So in particular circumstances, I think using certain types of drugs can help you overcome certain problems. I think you're right. ADHD is a good example of that. Adderall is a type of stimulant, and it helps. It's a stimulant that also affects the part of the brain that is responsible for allowing you to concentrate on certain things. So this is a drug that helps you to really deal with a lot of the problems of modern living, right? A lot of modern life is focused on, let's be really productive. Let's get stuff done so we can make money and live comfortably and raise a family and, you know, provide for children and provide for our neighbors and everyone around us. And so if that's your goal, if that's kind of what you want to get done, then a stimulant or you know, Adderall in the case of ADHD can kind of help you achieve those things. But of course, if you go beyond, or you make a habit of using certain drugs to aid you as a tool, they could potentially stop being a tool that you use in very particular situations and instead become a regular part of your life, such that you are dependent on that drug in order to get something done. And that's where things get potentially harmful, is if you're dependent on a particular drug. I think a lot of that harm comes not necessarily from what the drug might do to you itself, but rather everything else that you might be intaking into your body while you're trying to get that drug. For example, Monster Energy drink is not just caffeine. It's also a lot of sugar and a lot of other stuff that increases acidity. So if you're drinking 1 cup of coffee every day, you're probably not going to experience a lot of side effects of that. But if you get tolerant to caffeine, such that you now need to drink 3, 4, 5 cups of coffee, or you need to down like 3 to 4 Monster Energy drinks every day to just keep running, then what you're doing is potentially wearing away physically at, say, the inside of your stomach. Drinking too much coffee, drinking too much Monster Energy can give you ulcers. That's kind of holes that form in the mucous membranes of the inside of your stomach. So in that case, it's not necessarily the caffeine that's doing the damage, but because you are dependent on the caffeine and you get the caffeine through coffee, which is acidic, or through Monster Energy drinks, which are acidic, you're causing other damage to your body by drinking tons and tons and tons of that stuff. So this is something I think is important to keep in mind. Even if a drug is potentially safe in moderate amounts, the method by which it's delivered could matter a lot. This makes me think of the difference between smoking cigarettes and vaping. What we know based on current evidence, what evidence does exist, vaping is still a relatively new thing. So I think we still need some good longitudinal studies we'll talk about what a longitudinal study is in a second. But we still need these kind of long-term studies to see the effect. But based on what we know right now, vaping, if you're going to take nicotine, if you for one reason or another decide that must be in your body, then vaping does tend to produce relatively better health outcomes because you are not taking in the slew of other chemicals that are within cigarettes. Does that mean that vaping nicotine is safe? Not necessarily. Nicotine in and of itself, if you overdo it, can cause its own problems. But you have to consider what you're taking that drug with. What else is entering your body as well? Sorry, I'm just reading what you wrote here, Bree. Right. Yeah. No, and I think that's a good idea. Is right. I think moderation really is the key for a lot of things in life, but especially for drugs. You have to just realize that there is something physically happening within your body when you use a drug. You may be using that drug as a tool to solve a very particular problem, but you have to keep in mind that there's always the risk of developing a dependency, of becoming tolerant to that drug, and ending up taking more of that drug than is actually healthy for you. So be aware of that. That would be my advice. We take drugs because they aid us, but overdoing it or not keeping track of how much you're taking or how much you're really benefiting from it can lead you to some problematic drug abuse. All right. Before we move on from here, I want to open things up. Do you all have any questions about drugs in general? I mean, anything that we didn't cover, something that you've been curious about that you want to talk about? Again, this is a weird opportunity because I imagine there are not many chances you get to just openly talk about drugs and figure stuff out. So I'm happy to use this time for that. Does anyone have questions they want to ask?
I don't know if you might have an answer, but I kind of use this as my hypothesis, number 6. What if some, certain types of drugs, such as LSD, for example, and like you give it to an artist, how would that affect their art?
Well,
Would they?
as a matter of fact, it turns out artists do tend to generally like hallucinogens as a category of drug. LSD is so what a lot of creatives will do, and I use that term very broadly, so that could refer to artists. I've heard of people who do a lot of computer programming, people who have these types of jobs where they need to focus really intensely, but also let their mind kind of go every which way and get feel kind of creative in that sense. It's called divergent thinking, where your mind kind of goes this way and that way and that way just to explore ideas. Some creatives report doing something called microdosing, which is when you take a very, very small amount of the drug so that you produce that effect that you want, that kind of like feeling of kind of sensations being more intense and your mind kind of going places that it wouldn't otherwise normally do. But the idea is not to get high. The idea is not to get just absolutely demolished on the stuff. It's the goal is to just alter the way you think slightly so that you're able to, again, for example, think divergently, something like that. So my impression is that a lot of artists use drugs for the same reason, is that it gets them to think differently and therefore can help inspire them or help to help them at least feel more creative. Now we can argue back and forth about whether they would be that creative whether they were taking the drug or not, but at least people report that experience. That's my understanding. Does that kind of tap into what you were thinking, Theo?
Yeah.
Yeah, people do report that. I think especially with artists who do a lot of, I mean, you're visual art, especially if you're painting or you are creating something in, say, like, Photoshop. Having certain visual sensations be more intense can, for some people, be helpful in kind of feeling their art, if that makes sense. Yeah, that is a thing that people report. Mm-hmm. Yeah, I think that kind of highlights something else, is that drugs, although they generally have an effect on people, depending on who you are and your own body chemistry, some drugs may have a slightly different effect, or it could be that you are just really sensitive to painkillers. And so something like ibuprofen is just enough to get rid of that pain. And maybe something like oxycodone is almost overdoing it, so to speak. I think they give people these kind of harder painkillers because surgeries like getting your tonsils. I don't know if everyone realizes the backstory here, but Brie had tonsil surgery. Those kinds of surgeries can be very painful for some people. So I think they prescribe stronger painkillers in case the ibuprofen's not enough. I would say, I mean, I'm not your doctor. I'm not going to give you advice, but if, say, the ibuprofen is enough, there's no reason to take the oxycodone unless you absolutely need it. It really is just a matter of to what degree do you want to not feel that pain? Yeah. Yeah, and oxycodone, because it's stronger, it probably will make you tired. Yeah. So if if ibuprofen's enough, you're probably good to stick with ibuprofen. But again, I'm not a medical doctor. Don't listen to me, but that's that's my experience. Other questions about drugs in general? All right. Well, the last thing I want to say about this is, again, I want to remind everyone that if you yourself ever struggle with a drug dependency, or you know someone with a drug dependency, especially if you know someone else, the solution is usually not to think of another person as, don't stigmatize drug use. Don't demonize people who use drugs. Remember that chances are someone started using a drug as a tool to solve a problem. Rather than make them feel bad for doing it, I think the best solution is to help them figure out what that problem is. What problem are they trying to solve? And can they be helped to find an alternative solution to that problem? If the drug is causing them a problem, if the drug itself is causing them a new problem, then the solution may not be to take more of the drug or to continue to take the drug, but rather to take a step back, look at and say, what is this drug doing for me, and can I find an alternative solution? That isn't necessarily alternative medicine. If it's a legit medicine, you probably need to use it. But if it's a dependency, there may be alternative ways to deal with that problem. So see drugs as a tool that people use, not as this like mythical thing that steals someone's soul away or makes them evil. That's just not how that works. People are willing to do some pretty, quite frankly, shitty things when they are dependent on drugs. But remember that they are just people trying to solve a problem for themselves. So support them. Do not stigmatize them. All right. That concludes the chapter on consciousness. We're done with drugs. We're done with sleep. We're going to be taking a little bit of a pivot here. And now I want to start talking about human development. And it's a bit of a pivot because everything we've been kind of talking about particular capacities, particular abilities that the mind has, learning and memory and aspects of consciousness and sensation and perception. And now what we're going to try and do is figure out, how does all of this stuff change across time? How does thought and behavior shift between the moment sperm and egg meet and you have a single cell? How does your psychology, your nervous system, develop from when you are a single cell up until you are an adult? That's the question we're going to try and tackle. So in a lot of ways, we're going to look at how these kind of biological and psychological changes occur throughout the lifespan. And we'll be looking, I'm going to try and incorporate what we've gone over so far. That is the biology of your nervous system. How does the biology of your nervous system change across time? How does sensation and perception change? How does your ability to learn certain things change across the lifespan, and your ability to retain what you've learned? And then aspects of your consciousness as well. If you think back to your life so far, you could probably list a couple of things that have changed across time. For example, learning is one of those things that seems to be heavily influenced by development over time. When you were a child, you picked up a language. Chances are no one sat down with you and taught you the language in the same way that they might teach you a language now in college, right? When you're like, between 1, 2, 3 years of age, a child is sitting there and just listening to people talk, and just miraculously, almost magically, it seems like they pick up on the words, they learn to string those words together, they learn to form their own sentences. They learn that language almost on their own. That's impressive, right? However, you compare that to now, if you're taking any kind of foreign language now, something that you are not accustomed to, it's probably much harder than it used to be. You're not picking it up as quickly. The idea is that there's actually a particular set of kind of mechanisms within our brain that are active around the time when we are young and we need to acquire a language. And then that actually turns off later in life. You don't need it anymore. You've already learned that language. And so now your brain starts to dedicate energy and resources to developing other things because you already have your language. So now you try to learn, say, Spanish in college, and it's much harder. It might take years and years and years for you to learn what an infant might learn in, a couple of months to a year, something like that. So that's one aspect of your learning that has changed across time. If you think about consciousness, chances are your experience of life, how you think about yourself, how you think about other people, the values that you have, the goals that you have in your life, those aspects of consciousness, those have probably changed from when you were young. They're probably different now than what they were when you were 10 years old or when you were 5 years old. So your conscious experience has changed. So we're going to look into that. We are going to trace from when you were a single-celled organism, a zygote, all the way up to now. And right now, everyone is in a very interesting, kind of cool developmental period. So everyone here should be, as far as I can tell, should be in this developmental stage. It's called the formal operations stage, and it's when you are capable of what's called hypothetical deductive reasoning. That seems to be the capacity that makes, first off, humans in general unique, relatively unique compared to other organisms. And it's something that comes online about puberty, and then you're pretty much stuck there for the rest of your life. And some people don't develop it very well, other people do. So we're going to see how we get to that. How do we get from a single-celled organism up to some of the more complex psychological abilities that we have as adults? I think that'll be a fun journey. To make that journey, though, I need to first teach you two things that will prepare you for the next 2 weeks of lectures. So in this first week of lectures, we're going to talk about prenatal development. That is development that occurs before birth. So everything that happens within the womb, within the uterus. Then the next week, we'll go over everything that happens after birth. Once you have a child, what happens with that child? How does their psychology develop? So to prepare you for those two sets of lectures, I need to first introduce you to some of the research methodologies that people who study human development use to scientifically study it. So let's think about this for a second. If you had to study human development, you had to study how psychological traits or abilities change across time. How would you study that? How would you study how things, as you progress from age 2 to 4 to 6 to 10, how would you study how those traits change? If you want to know how 5-year-olds think versus 10-year-olds, how would you study that? Let me refine that question a little bit. Let's say that we are studying intelligence. How would you study how intelligence develops over time in, say, 5-year-olds versus 10-year-olds?
I mean, you could give them both the same task to do or test and see which does better.
Okay, great. So you could take a bunch of 5-year-olds and you could take a bunch of 10-year-olds and you could give them both the same test, see how they compare. Absolutely. We'd be able to see how 5-year-olds perform, how 10-year-olds perform. What other ways could we do that? There's at least one other way that we can do that. So we can get different groups of people of different ages and test them, or If I wanted to know how your intelligence changes across time, how would I do that? What would I have to do? So one of the limitations of recruiting 5-year-olds and 10-year-olds and then giving them the same test is that they're different people, right? If you're getting a bunch of 5-year-olds together and a bunch of 10-year-olds together, there are two differences between those two groups. One is their age. One group is 5 years old, the other group is 10 years old. But the other thing that's different is that they're different people. You're not accounting for individual differences. So to do that, we have another design that we called a longitudinal design. And this is when you recruit a group of people, and then you track how they change over time. So you actually might follow them for 5 years, assess them when they're 5, and then assess the same people when they're 10 years old. That's a longitudinal design. So we have two designs here. We have longitudinal. This is when one group of people is studied across time. And we have a cross-sectional design, which is different age groups are studied at one time. All right. Let's think about the advantages and disadvantages of each. So how would you describe the advantage of a longitudinal design relative to a cross-sectional design? Just based on these definitions, what do you think the advantage of a longitudinal design is?
Better when you have the same people and you watch them grow and develop over time compared to having a bunch of different people.
Exactly, perfect. So the big advantage of a longitudinal design is that it accounts for what are called individual differences between people. You're right, with the cross-sectional design, we don't know whether the differences are due to age or whether they're due to the individual dispositions, the family histories of each person, or the genes that they inherited, et cetera, et cetera. That's the big advantage. And so in this way, a longitudinal design is superior to a cross-sectional design. You'll actually see this if you go and you start looking for studies on human development, or you just want to see how things change across time. Longitudinal designs are the gold standard. If you see a longitudinal design, someone put a lot of effort into that, because it's often very difficult to pull off. Why do you think it would be difficult to pull off a longitudinal design? What do you think the disadvantages are?
If someone doesn't want to do it anymore or they drop out, and it could cause an effect of everybody to want to just stop participating in the experiment.
Absolutely. That's called participant attrition. So there's the risk of participant attrition, which means that they might drop out. So that is, if your whole experimental design depends on you being able to bring in a group of 6-year-olds that you recruited in, you want to see how their intelligence changes between 6 and 10 years old. If they, move out of the area, let's say that there's just a life circumstance. Maybe they get bored with the experiment. They just don't want to come back. But maybe the parents move, and now the child can't come back. Maybe you've collected data when they were 6 and when they were 8, but then they moved out of the area when they were 9, and now you can't test when they're 10. Well, now you've collected all this data, and you can't really analyze it. You can't analyze that data in the way that you wanted to, because you don't have that last bit of data. So now you've spent all this time following these participants across time for years, probably sending them emails, meeting with them, developing a personal relationship, and now you just have to throw all that away. That's a huge cost, participant attrition. And it's especially costly for longitudinal designs because longitudinal designs are expensive. I have a hard enough time getting my students in Psych 101 to participate in a survey that takes maybe 30 minutes. So if I were to try and get people to not only take a survey, but take it twice, or for people to actually come into an in-lab experiment and let me record things about them, and then they come in, say, 2 months later or a year later, the only way I'm going to do that is if I pay them, if I give them money. And that's often what you'll see is longitudinal experiments will involve some amount of participant compensation, some amount of paying them money to come back. So it's expensive, it's hard to do. And to get money to do this kind of research, you either need deep pockets of your own, or you need to earn grant money from institutions or from companies, which is not easy to get. So longitudinal designs are relatively rare. So when you see them, pay attention to them. They tend to be very good, high quality data kinds of studies. So then why would we ever want to do a cross-sectional design? Well, it's easier. It's a lot easier. If you're getting people of different age groups, bring them all in at the same time, that's all you need them to do. They come in for one session, they complete a survey once, they run through an experiment one time, and then they can go. You never have to see them again. So it's much cheaper, it's much easier to collect the data. So the vast majority of studies that you'll see are cross-sectional because they're easy to pull off. There are a lot of drawbacks to them though, and of course the biggest one is you can't account for differences between people. You don't know whether differences observed between 5-year-olds and 10-year-olds are due to their age or due to their individual differences. And there's another thing that I think we don't tend to think about until it's pointed out. But let's say that you want to compare different groups of 20-year-olds. Okay, so let's say you have a hypothesis. You have this idea that 20-year-olds behave in a certain way, or 20-year-olds have a certain experience. They have certain psychological traits, maybe compared to like 30-year-olds or something. Okay. Well, cohort effects refer to similarities between people that are due to the fact that they shared historical events. If you recruit 20-year-olds who are alive now, they're alive in 2021, 20-year-olds in 2021, and you compare them to 20-year-olds from 1960, how similar do you think those two groups of 20-year-olds will be?
Not very.
Not very. So just more different than necessarily similar, or?
Yeah, more different, because I know like back then there's a lot more responsibilities for like late teenagers, early 20s, where like it was kind of a societal standard to start a family that early.
True. Yeah, people started families earlier. They reproduce earlier. They are not in school as long. So in some ways, 20-year-olds are probably at least less further along into their adult lives than people from the 1960s may have been. Maybe. I actually buy into that. I think that's true. What other ways do people, 20-year-olds in 1960 differ from people from 20-year-olds in 2020, 2021? Let's say we're examining romantic relationships or sexual behavior. What would be different?
I mean, I would assume the person in the 60s would have less out of wedlock sexual relationships, just because that was how the culture was back then.
Yeah, so maybe things were a little bit more restricted, right? You couldn't be as out about being non-heterosexual back in the 1960s. That is, gay, lesbian, bisexual, etc. So that's something that's going to be different. So one of the differences, one of the cohort effects might be that people from the 1960s had this similarity, this shared experience where they were not allowed to express their sexuality if it was different from heterosexual. compared to people in 2021 who are arguably much more free to do so. Probably the options that you have for romantic relationships are different too, right? Now we have tons and tons and tons of online dating services and apps, Tinder and Bumble and everything else that's available now. The method by which we form romantic relationships has changed because of the historical circumstances of our technology. We have much more sophisticated technology now than we did before. And so who pairs up with who, what kinds of experiences they had, how many sexual partners they could have had access to back in the 60s versus now. If you want to find a casual sexual partner, you can probably find one on Tinder. Now, whether you have success doing so is probably different depending on who you are, but the options are there. So you have tons more options, potential options, than you used to. So that's something that you have to account for. And again, that's not accounted for by a cross-sectional design. In fact, it's not really even accounted for by a longitudinal design. So it's really a weakness of both. If you want to get at cohort effects, there's a third design that you need. And this is called a cross-sequential design. Essentially what you want to do is you want to combine the two. You want to do both a longitudinal and cross-sectional experiment all in one. So what you'll do is you'll recruit people of different ages and then study those people across time. So let me orient you to this image because it's actually very clear once you figure out what's going on here. Along the bottom here, let's say that we're testing people. So we're testing intelligence, okay, across time, how intelligence develops. And here are years of testing. So we're going to test people in 2002, people in 2004, and then again in 2006. Along the y-axis here, we have two groups of people that we're recruiting. People who were born in 1994 and people who were born in 1996. So we're going to track these two groups of people across time. That means at 2002, we have a group of 8-year-olds and we have a group of 6-year-olds. Then as we track each group across time, this 8-year-old turns into 10-year-olds at this time, they turn into 12-year-olds at this time. And these guys turn into from 6 to 8 to 10. So each of these arrows tells you the kinds of comparisons you can make with this design. If you are tracking just how these individuals change across time, this is a longitudinal comparison, the blue arrows here. So you can see how these people born in 1994 change in intelligence between 8, 10, and 12 years. Same with people born in 1996. The cross-sectional comparisons are here. If we want to, again, compare two different groups of people of different ages at the same time, that's what we do right here. Well, what a cross-sequential design allows us to do is account for these comparisons. These are the cohort comparisons. So this allows you to control for those historical influences. How does it do that? Well, what we can do is we can compare 8-year-olds, data from 8-year-olds that were born at different years. So if something happened in 1996 that is substantially influencing their intelligence, let's say that there was some chemical outbreak, okay? There was serious problems inflicted on children. I don't know, there was something happened, the groundwater got tainted. This isn't far-fetched. Actually, I lived in Michigan for a couple of years. I think I mentioned this a while back, but there's a city up in Michigan called Flint, about like an hour north or so of Pontiac and Detroit, where maybe more than an hour, where for a while it was known that for several years the water system was actually, there were things being poured into the water system that served the population there that actually had a significant impact on people's development there, on their intellectual development. So there were cases of all kinds of problems happening in Flint, Michigan. It's still going on to some degree, but I think that they're addressing it. So let's say that in 1990, let's say this, 1994, the water was tainted. And so these children were exposed to a historical event that these children were not, born in 1996, were not. So what we can do is we can control for that historical circumstance by comparing 8-year-olds at this time with 8-year-olds at this time. If there are any differences between these groups due to the groundwater event, we'll be able to detect it right here. I imagine this will also be something that people will do in response to the pandemic. I think that there are probably some things about our development, some circumstances, maybe especially for children, that have changed by virtue of the pandemic, people having to be isolated for long periods of time, et cetera, et cetera. So it's very possible that, say, children who were born in 2018 might have very different developmental circumstances to those who were born in 2020. Or maybe, for example, if, say, adolescents who came to age during the pandemic, at a time of life when you are, learning to get along with people, you're part of a social network, you're making friends, and those are really important to you. Being isolated for a year, maybe that could have some kind of effect on people's development, on people's social development. So there might be a big difference between adolescents who had been born, say, people who are adolescents, or they started their adolescence in 2018 versus people who started their adolescence in 2020. We won't know whether that cohort effect matters unless we do a cross-sequential design like this. All right, so these are the three really big designs that we have for examining how psychological traits change across time, for studying human development: longitudinal, cross-sectional, cross-sequential. I'll warn you, these will be on the test. So of course, you should probably learn to distinguish them. I also believe this is one of those things that I put on the final exam as well. Okay, that's the first thing I need you to understand: the research methodologies that people who study human development use. The second thing we need to talk about is what's known as the nature versus nurture debate. This debate is about, well, what causes change in development? Oh, yeah, Eli, sorry.
Sorry, I didn't mean to unmute myself. Go ahead.
You're good. What if these changes are happening across time? If there are differences between 5-year-olds and 10-year-olds, there are two possibilities here. One, the difference between a 5-year-old and a 10-year-old could be due to biological development. That is, there's something that actually physically changes within the body that is responsible, or that changes within the brain, that is responsible for why 5-year-olds think the way that they do and 10-year-olds think the way that they do. Language acquisition is a good example of this. When you are really young, biologically, physically, there is something active in your brain that allows you to acquire a language more quickly. And then as time goes on, you will just naturally lose that ability, such that it's harder to learn a language after a while. That would be attributing development, a change in development, to nature. Nature is biology or genes. It could also be due to a person's nurture or their environment. That is, the experiences that they have throughout life. And no doubt, the differences between a 5-year-old and a 10-year-old could very much be simply because the 10-year-old has had 5 more years of life and all the experiences that come with it compared to the 5-year-old. So that would be environment, their family, maybe the culture they grow up in, the values that they were surrounded by, that they were instructed about, the friends that they made, the kinds of activities that they participated in, environment, the experiences that you have throughout life. So this is an interesting question. How much of a change in someone's psychological traits is due to their biology versus their environment? Well, I will start this by skipping right to the end. Turns out this debate is dead. We know that it's not nature versus nurture. We know that these things are not at odds, and we know that it's not ever one or the other. For every known psychological trait, for every trait that we have ever measured, We know at this point, we actually have data, and I'll talk about this data in a second. We have data to show that there is a genetic, there is a biological component to the development of that trait, and there is also an environmental component, a nurture component to that trait. So we know it's both. And it really depends on the trait. So for example, I don't talk about personality too much in this class, but there is a very well-validated personality test. And I'm not talking about the personality tests that you'll find on like Facebook or Twitter that are, you know, garbage. These are personality. This is a personality test that has been. It was actually developed back in the 70s, and it has been used in psychological research ever since, and it has really stood the test of time. And there's tons of evidence behind it. It's called the Big Five. Big Five personality traits. Things like extroversion, agreeableness, openness to experience, conscientiousness, and neuroticism, which has now been relabeled to emotional stability. These traits, what we've done is, and I'll show you how we've done this, but they've tested this and they've found that it's about a 50-50 split. About 50% of the differences between people on these personality traits can be explained by a person's genes. That is what they inherited from their mother and father through biology. And about 50% of it can be explained by the experiences that they've had throughout their life. But it isn't always equal. Sometimes one contributes a bit more than the other. And this is actually kind of a it's not a secret, but it's kind of one of those dirty truths, is that it turns out if you measure intelligence and you try to figure out how much is due to nature versus nurture, a huge part, more than 50% of the differences between people in intelligence is due to biology. Estimates range anywhere from about 50% upward of 80%, and you tend to see more evidence that it's closer up to 80%. That's not to say that people's experiences don't shape their intelligence. They do. You want to send people to school. You want to try and push them beyond what their genes have kind of given them. But it turns out genes contribute a lot to how intelligent a person ends up being. And we can talk about that in more detail. I used to show a video on that, but I actually have a different one that I've prioritized given time constraints. So now the debate is how much of something is due to nature and how much of something is due to nurture. And this has been a much more fruitful line of research. So then how do we study this? Does anyone know how we would actually distinguish whether something is due to genes versus your experiences? Anyone know that or want to take a guess at how we would do that? The secret is twins, identical twins. Identical twins, which we'll learn about, they are called monozygotic twins. They come from a single zygote, monozygote. Sperm, egg, they meet, they create a single-celled organism. Then when you have an identical twin, that little zygote splits in half. It shouldn't split all the way in half, but when it does, what you end up getting are two copies of the exact same individual. So identical twins share 100% of their DNA, of their genes, which means that if we study twins, any differences that we observe between them must be due to differences in their experiences, differences in their environment, because we know that their genes are exactly the same. So people have done some really cool research using twin studies. And what I want to do is I want to showcase one of the lead researchers in this field. There are huge institutes dedicated to twin studies because we realized as a society just how useful this information can be. Her name is Dr. Nancy Siegel, and I've met her a few times. She's a very nice person, and I have a video here. It's about 11 minutes long. I want to show you. I think we can get through it before the end of class, where she introduces some of the weird things that you can discover when you're doing twin studies, and some of the really just how much of a scientific powerhouse it is to
to be able to do research on twins and figure out how much of something is due to nature versus nurture. So let me share this real quick. Oh, sorry. Here we go. All right, let me know if anyone cannot hear the audio, but it should be working.
Yeah, I can hear it.
Let's talk about twins. Twins turn heads wherever they go. Seeing two identical infants, children, or adults is irresistible, causing us to peer into baby carriages, stare into playgrounds, and even ask rather personal questions such as who is older, who is smarter, and who decides what both of you will do, as if everything twins do is exactly the same. Society tells us that we all differ in appearance and behavior. So when we encounter two people who look and act so much alike, it challenges our belief in the way that the world works. But we find ourselves intrigued and drawn into twins' lives, trying to understand them. For most of human history, psychologists believe that we are largely products of our environment. But twin research is teaching us that so many more of our behaviors than we ever would have imagined are influenced by the genes. There are two kinds of twins, identical and fraternal, and both are essential in twin research. Identical twins result when a single fertilized egg divides within the first 14 days after conception, and these twins share all their genes in common. Fraternal twins share half their genes on average, just like ordinary brothers and sisters, and they result when a woman releases two eggs at the same time that are separately fertilized by two separate sperm. We can compare the similarity of identical twins in running speed or in how fast they solve math problems to the similarity of fraternal twins. And if identical twins are more alike, and they usually are, this tells us that the genes play an important role. Now, most studies use identical twins raised together, but studying the rare pairs of identical twins reared apart is even better, because if identical twins raised apart are as alike as identical twins raised together, this is even more compelling evidence that genes are important in our development. Think about the identical Jim twins, Jim Lewis and Jim Springer, who grew up in different Ohio cities. They didn't meet until they were nearly 40, and they discovered that both twins bit their fingernails down to the nub. They both drove light blue Chevrolets. They both had mixed headache syndromes beginning in their teenage years, and they both liked to vacation on the same 3-block strip of beach in Florida. The Jim twins also both named their sons James Allen. Now, James is a fairly common first name, but Allen is a much less common first or second name. Both of the twins had worked part-time in sheriff's offices and part-time at McDonald's. And they loved to scatter love letters around the house for their wives. And in a curious twist, both twins had married women named Linda, divorced them and married women named Betty. But then one of the Jim twins divorced Betty and married Sandy. We know that divorce is a partly genetically influenced trait, so you can imagine the worry on the part of the remaining Betty. Now, what about the twins Jack and Oscar? They had dramatically different environments, but even that did not prevent them from amassing a whole list of similarities that surpassed even those of the Jim twins. Jack was raised Jewish by his father in Trinidad, and Oscar was raised Catholic by his grandmother in Nazi Germany. And when they met for the first time, they discovered that both twins liked to wear rubber bands around their wrists, They thought it was funny to sneeze loudly in elevators. They both washed their hands before and after using the toilet. And they both read books from back to front. And they hated floral centerpieces because they said it blocked the view of the person seated across the table. How do we explain these similarities? Well, it could be that reading books from back to front suggests impatience, or sneezing loudly in an elevator is a cry for attention. But regardless, the fact that we see these similarities repeated in identical twins so much more than fraternal twins tells us that genes do play a role. Dorothy and Bridget, reared apart twins in Great Britain. They show us that you don't have to live with somebody to be like them. You only have to share their genes. When they met for the first time as adults, both twins were wearing 7 rings, 3 bracelets, and a watch. And the similarities did not stop there. The twins described themselves as short-tempered, disciplined, and strict. They liked the same brand of perfume. They liked the same kinds of books. They had worn nearly identical dresses to their weddings and carried nearly identical floral bouquets. And they remind me of the identical reared apart twins, Mark and Jerry. Mark and Jerry grew up in different cities in New Jersey, and they didn't meet until they were in their early 30s. They were both volunteer firefighters, but their signature quirk was holding a can of Budweiser beer with the pinky finger underneath. And you can see that they also carried huge key rings that they attached to their belts. Belts had huge buckles on them. They both threw their heads back sharply when they laughed. They were 6'4", bald, and heavily mustached. And when I took them out to dinner, I discovered they had a shared passion for Chinese food and for steak served extremely rare. And I also studied Barbara and Daphne, the Giggle twins. My colleagues and I affectionately call them that because when they met for the first time, they discovered that they laughed uncontrollably with each other and with nobody else. And they had the same crooked pinky fingers, the same disinterest in politics, and they drank their coffee cold, black, and without sugar. These twins had had a first miscarriage in their first pregnancy, followed by 2 healthy boys and a daughter. That may not be so surprising, because female physiology may in fact the sex of our children, and in this case, the physiology was perfectly matched. Shortly after they met, they concocted a drink called Twin Sin that was made of vodka, blue curacao, creme de cacao, and cream. My colleagues and I thought it was a little curious, but the twins thought it was just delicious. I finally want to mention 2 sets of identical twins, males, born in Colombia, South America. 1 pair from the city, 1 pair from the country. We don't know how this happened, but early on in the premature nursery, 1 newborn twin was accidentally exchanged with 1 newborn twin in the other pair. So these 2 sets of brothers grew up thinking they were fraternal twins, when in fact they were completely genetically unrelated. When they were 25, the truth was discovered and the real pairs were reunited. I went down to Bogota to study them, and I discovered that the personalities of the reunited twins aligned almost perfectly. In one case, the twins were outgoing, gregarious, risk-taking, and in the other case, they were introverted, a little cautious, a little restrained. Again, we don't fully understand the reasons behind these similarities, but seeing them repeated in identical twins, more so than fraternal twins, gives us a genetic perspective on human development. Now, we need to think seriously about these findings because they have huge implications for how we raise our children and how we can all make the best of our abilities, our goals, and our dreams. You know, in my experience, parents of 1 child are environmentalists and parents of 2 children are geneticists. And I say that because parents of two children realize rather quickly that what works for one child doesn't work for the other. And that's because children come into the world with their own genetic predispositions that lead them towards certain activities and places and opportunities. Parents have to have realistic expectations about each child. Two dancing parents may not have a dancing child, because even though each parent shares half their genes with the child, genes get reshuffled in each generation. You know, I tell parents, you don't really bring up your children, they bring you up, because each child evokes certain treatments and certain responses from each of their parents. A child with athletic abilities should be given opportunities to play sports. An artistic child should be given opportunities to paint and to draw. And a shy child should be given opportunities to speak up more, encouraged gently to do so. In this way, parents can make a huge difference in the lives of their children. And I also want to acknowledge the teachers and the mentors and the managers who work so closely with twins and others and affect their lives. As a psychology professor, I identified a very promising undergraduate student, one who showed real ability, talent, and drive. But he was the first in his family to go to college, and he lacked guidance and opportunity. I work with this student on a number of projects, and today he is an advanced graduate student at the prestigious University of Michigan. Back to our twins. Twins are not just mere objects of fascination. Just by being themselves, just by acting naturally, they give science a powerful tool for understanding genetic and environmental influences on behavior. And in this way, they tell us about our humanity, why we are the way that we are, and how we got that way. Thank you.
All right. So I realize we're just about out of time, but I hope that is something that you can kind of walk away with and ponder a little bit is just how much of your life and how much of who you are is potentially because of your genes versus your environment. And we are constantly trying to tease that apart. All right, so those are the two things, research methodologies and nature versus nurture. Understanding these things, I think, will help with the lectures for this week. Again, first on prenatal development, next week on postnatal development, or everything that happens after birth. So everything is available, should be good to go. Any questions before we break? All right, well, thank you all for being here, and you know where to find me if you need me. Thanks all. Hey Eli, do you have a second?